Hi everyone, and welcome back to another video with me, Elizabeth Bishop, your Autodesk certified instructor. In today's video, we're going to be going through how to design a 3D printed enclosure for an Arduino Uno. So let's jump into Fusion and get started. I'm going to start by selecting a hybrid design type. Hybrid is more flexible and allows us to explore our design more freely until we decide on a structure within our files browser. We will explore this in more depth throughout the video. So I'm going to select Create New on that and save my file. I'm going to be using a mix of different file types in this design. Some I'm going to create in place and some I'll import as components that other people have designed. Starting off, I want to create the first component, which is going to be the actual enclosure. To do this, I want to go into the Assembly tab here and create New Component. And this is because I'm doing a hybrid, so a mix of different components. I'll call this Case for now. Once you're in a component, you can activate it with this toggle button. If I want to go back to the top level, I can click this one. And if I want to work solely in the case, I can click this one. You'll notice that there is an anchor here, which means that Fusion will automatically ground the first component that you make to its parent component. The difference in symbols is my top level is an assembly with the 3 blocks, and this one is currently a part. Until I create multiple components in it, it will remain as a part file. We want to ensure that the enclosure is the right size for our Arduino, so we need to know the dimensions of the Arduino. We can find these in a few different places. The first of which is going to be most useful to you, is to physically measure the Arduino you have in front of you using some calipers, and use the dimensions of this to drive your design. I'll be doing a lot of this throughout the video. Another place to find dimensions is if you have a 3D model of the Arduino that you're going to use. I found this one online. So we can open up this design and we can check the dimensions on there using the Inspect tool. So using the Inspect tool, I can check from this edge to this edge, and that gives me a dimension of 53.34. I'll note that for later. And from this edge to this edge, 68.58. These are very similar to the dimensions on the Arduino I have in front of me. I'll close that file for now. The final way we could do this is by looking on the Arduino website. So opening up the Arduino Uno R3, which is the one I'm using, I can scroll down here to the datasheet, which is a PDF, and on one of the pages you'll find one with the dimensions. These are a little smaller than the one that I have in front of me. Another great thing you can look at is using the Eagle files. So you can open up Eagle files inside Autodesk Fusion Electronics. So downloading the zip file, I can head back into Fusion. In my data panel, click Upload and drag in the schematic and the board design. When we do this, Fusion detects that these are electronic files and it asks if you'd like to create an electronics design. I'm going to click OK and do that. We've then got the schematic and the board design based directly from the Arduino website. If you were designing your file directly in Fusion and doing that board design and then wanted to bring that into the 3D workspace to design around, this is what you could do. And you can see that that contains both the board design and the schematic. Going to the 2D board design here, I'm going to switch from 2D PCB to 3D PCB. Now, how much you get in this 3D design will depend on the libraries that are contained with it. You'll notice that there's some warnings here, which mean that some of the components do not exist within the 3D space. And we can see that we have some flat placeholder components. But crucially, what I have is the board as it's supposed to look like and the whole design. So I'll just use that Inspect tool to check on here as well. So going from edge to edge, got 53.34, very similar to that other one. And from this edge to this edge here, 58.58. Again, similar to that 3D design that I've got there and the physical dimensions on the design I've got in front of me. For now, I don't need to use anything more in the electronics workspace, but as I said, it is great if you're designing your PCB directly in Fusion and then want to link that to a physical 3D enclosure. I'll close this for now because I don't need it in this design. I'm going to start off by creating a sketch. So in the Solid tab, Create Sketch, and I'm going to put this on the XY plane. When you're 3D printing, it's good practice to work with your designs as they would be flat on the bed, in this case the XY plane, and then you build up the part in the Z plane. So creating my sketch on the XY plane, and the first thing that I'm going to do is to create a rectangle which will define the size of my enclosure based on the Arduino. So I'm going to create a rectangle and choose a center point rectangle. Selecting my origin as the home point and just moving my mouse out, this opens up the dimensions. So I'm going to do this vertical dimension as 53.3, and then I'm going to press tab to switch to the next dimension, and that one's going to be 68.6. That's roughly the size of the Arduino I have in front of me. Next, I want to define in this sketch some circles which will define the pins that are going to hold the enclosure together. So I'm going to create circle, or C on the keyboard is the shortcut for that. And I'm going to place these randomly for now, and then we'll locate them using some dimensions. Now I want all of these circles to be 2.8 millimeter in dimension. So I'm going to dimension the first one. So clicking on that and entering 2.8 millimeters. Now I could dimension all of the circles, or you can use a constraints trick to set the size of them all to be the same. So selecting all of them using the Shift key held down. So I've got all four there, and then going into constraints and equal. This means if I change the dimension of one of them, say to 5 millimeters, they will all update. This helps with the design if you're making changes, you're not sure what sizes things need to be, but we know that they all want to be the same size. So this size is based off the hole size in the Arduino being 3.2 mil. I want these pins to be able to go through the holes, so they need to be smaller than that, but I also want them to be big enough to 3D print. I now want to dimension the location of these pins on the board, and I'm going to do this from a datum point. It's good practice to always dimension from the same point when you're doing this. So starting to add in the dimensions, going from this bottom left-hand side. So clicking on this line and then the center of the circle, clicking to place the dimension, and then you can insert the number. So that's 14, and then from the bottom to there is going to be 2.5. I'll then do this one up here. So from the bottom up there to the center of that, that's going to be 50.7. From the edge to there is going to be 15.3. If you're unsure of these, you can always check it on that 3D model or the datasheet. Going from there to there is going to be 66.1. From here to here is going to be 7.6. Now this one up here is going to also be 66.1 from the left. I could add that dimension in, or I can use another constraint trick. So selecting the center of both circles using the Shift key to select both at once, and I'm going to click horizontal and vertical constraint here. This means that this circle is now vertically constrained above the other one. So I only need one dimension from here to here to fully constrain that. You'll notice that all my lines have now turned from blue, which means they're unconstrained, to black, which means they're fully constrained. It's good practice to always fully constrain your sketches to avoid ambiguity in your designs. I'll just tidy up my dimensions before I finish the sketch. This isn't essential, but I like to keep things neat and not have overlapping dimensions, just in case I need to go in and check anything. Before I finish the sketch, I just want to add an offset because this is the exact dimension of the Arduino, but we want there to be clearance inside the case. So modify an offset. I'm going to select that outer profile and enter a dimension of 1 millimeter outwards. This gives me just a little bit of wiggle room inside the case in case the dimensions aren't perfect. And before I finish, I will make these inside lines using Shift to select all four construction lines. So selecting those four and then changing the line type to construction, or X on the keyboard is a shortcut. You'll see that changes from a solid line to a dotted line. This will just make things easier when we're doing the extrusions in the next step. So once you've done that, you can click Finish Sketch, and this goes back to the solid working environment. I'm now going to create an extrude. So create an extrude, and I want to select all 5 of these profiles, so including those circular profiles. I'm going to drag that handle up and enter the number 22 millimeters. I've measured my Arduino, so I know that this is the size I need it to be. Creating a new body and clicking OK. This will enclose both the top and the bottom sides of the cases in this design. So at the moment, this is one solid block. I can show you that using a section analysis. So under Inspect and Section Analysis, I'll just open up the origin, view that briefly, and I'm going to do this through the YZ plane. It cuts the model in half and allows us to see inside the part. I'll just turn off that analysis for now. I'm going to create the shell, so I want to shell this out to create it hollow. So I'm going to do Modify and Shell. And you can either do this from a face, but in this case we want to shell the entire body. So I'm opening up the case here and finding the body for this part that we've created. And I want to set the wall thickness of the design that I'm working on. In this case, I'm going to use a wall thickness of 1.6. When you're designing for 3D printing, it's always important to consider your extrusion width, so in this case 0.4, and using multiples of your extrusion width. It'll give you a neater and cleaner print when you come to that final product. But I want this to be an outside thickness, so from the design that we've already done, and that's going to be 1.6, and clicking OK. You'll see that the block that we had there has just got a little larger, and we can turn on that analysis and you can see that the design is now hollow. It's starting to look a little more like a case, but we can't put anything inside it. Now I want to split this case in half. So I'm going to turn off my analysis and I'm going to create a construction plane. I'm going to use a mid plane, selecting my top surface of the box and my bottom surface of the box. Now the reason I'm using a mid plane in this case is because if I go back and I say adjust the dimensions of the box, this will still keep that split in the middle of the design. So now that I've got that construction plane, I can go to modify, split body. The body I want to split is that box, and the splitting tool is that construction plane that I just created. So clicking OK on that, you can now see that we have two bodies in that design, the top and the bottom. I now want to do some work on the bottom half of the case. So I'm going to hover over the bodies here to check I'm using the right one and hide body 2, which is the top in this case, so that I can work on body 1. I'm going to turn on the visibility of the sketch by selecting the eye. I'm going to use the extrude tool to create the pins here. So create an extrude, and I want to select the center of those 4 circles that I drew on that original sketch. Now you could set this distance arbitrarily, either on the pull handle or by setting the amount here. However, I wanted to show you a tip that you can use here. I want this to be able to update if I make any changes to the design. So the extent type, I'm going to change to object, and I want to select this top surface here where the 2 halves of the box meet. So selecting that, and then I want to do an offset from this. So I want the design to go 4 millimeters above there so that they extrude into the other half of the design. Viewing this from the front plane, you can see that's 4 mil above the edge of that design. It means if we ever update anything down the line, then it will update automatically. The next thing I want to do is to create some standoffs for the Arduino board to sit on in the bottom of this case. If you've ever worked with Arduinos before, you'll know that some of the components, the pins and the legs, sit through the bottom of it, so it won't sit flat on a surface. In order to do this, I'm going to edit the original sketch that I created. So right-clicking on that in the timeline and clicking Edit Sketch. So I'm going to create the 4 circles on the same origins as the other. So create circle, or C is the shortcut on the keyboard for that. And I want the diameter of these to be 4 millimeters. So I'll set the first one, and then I'll just create 3 further arbitrary sized circles. And I'll use that same trick with the constraints. So selecting all 4, holding down the Shift key to select all of them, and then using the equal constraint. It just means if I make any changes to these dimensions, we don't have to edit every single dimension. So finishing that sketch, I'll create a further extrude and select the outer profile on each of these pins here. And I'm going to drag that up, and I want the dimension of that to be 4 millimeters. Again, the operation to be join. And we can see there we've created those standoffs. I can now hide that sketch, and we can see the enclosure is starting to take shape. Now looking at this design, I think I'd like to add some fillets to the edge to improve the aesthetics of the overall case. If I was to add these now, it would fillet the outside edge, but not the inside with the shell. So I'm going to use the timeline to help me change this. So I'm going to drag the timeline back to before I made the shell, back when we just had the solid case, and click Modify and Fillet. I can add in fillets on each of these 4 edges. And you can drag the handle to see what size looks good. I think I'm going to set a 3 millimeter fillet and click OK. You can then drag the timeline back to the end or press the end arrow, and you can see that that fillet propagates through the design. So turning on the analysis, we can see that we've got that shelled fillet as well as on the outside edge. That's one of the things I really like with the timeline. If you forget to add something in, you can always roll your timeline back, add in the feature and roll it forward. And I want to do some work on the top half of the case. So this is body 2 for me. So I'm going to hide body 1 so I can see the inside face, create a sketch on that inside face. But I want to project through some of the geometry from body 2. So I'll orbit round, hide body 1 but show body 2, and then use the project tool. So create, project, and project, or P is the shortcut on the keyboard. And I'm going to select it to be a specific entity and the top of each of the 4 pins that I created before. Clicking OK, you'll see that we now have these 4 circles in a purple line. Purple line means it's being projected through to the sketch. I can turn off body 1, turn body 2 back on, and go back into that view there. Now I want to use these to create the holes for the pins in the top half of the case, so I actually want them to be a little bit bigger. So I'll set all 4 of these circles to be construction lines because I don't actually need them in this particular design. So holding down the shift key, clicking all 4 and changing to construction. You'll see they change to those dotted lines. I'll then use the center of each of the circles to add in those holes for the pins. So I want these to be 3.2 with a thickness of 1. So that means the larger circle is going to be 5.2. As with the other holes, I'm going to add 2 arbitrary circles to each of those center points and then use the equal constraint to set them all to be the same size. So selecting all 4 of the smaller circles, using the shift key to select multiple at a time, equal, and then all 4 of the larger ones, and setting that to an equal constraint. You'll see that the lines have changed to black, meaning that they are fully constrained. So I'll finish that sketch and use the extrude tool again to create these holes for the pins. So creating extrude and selecting the outside ring that I've just created on that sketch. Again, I'm going to use the advanced extrude features to set 2 objects, selecting that top face. Now this time I want an offset of -1. So the extent type, 2 objects, and then offset of -1. And that means they sit just under the edge of that case. And that's a join operation and clicking OK. I'm going to make it a little bit easier to use in reality. I'm going to go back to body 1 and I'm going to add some chamfers to the top of these pins to help them insert into those holes. So modify and chamfer and select the top ring around each of these pins. I'm going to add a chamfer size of 0.4. It's always important when you're designing for 3D printing to think about what settings you're going to be using when you actually come to the manufacture of the object. In this case, I'm using a layer height of 0.2, so 0.4 is a multiple of this. However, if you were using a layer height of 0.15, you may want to consider a chamfer of 0.3 or 0.6 to make sure it is a multiple of that. I'm now going to make both of these bodies into components within my case component. So body 1, right click, create components from body, and body 2, right click, create components from body. Rename these as the top case and rename this one as the bottom case. It's important to work with components correctly in Fusion, and this is particularly important when we're designing something for 3D printing, as we want to be able to export each component as a distinct item. This is also an advantage of using the hybrid design type. Hybrid gives more flexibility and less structure to our design. For example, here, making adjustments to our bodies for ease and splitting them into their own components later is much more straightforward in a hybrid assembly type. I'm now going to insert that Arduino Uno design into this one so that we can use it for driving the rest of our design here. Before I do that, I want to make sure I've got the top level component activated. I'm going to open my data panel and right click on that 3D model and insert into current design. Hiding the data panel, I'm going to roughly orientate this to how I want to use it in the design. So I know that it definitely wants to be flat, so I'm going to rotate by 90 degrees there, and I know I want the ports to be on the left, so I'll take that to 90 degrees there. However, I don't need to position it directly in the right location, as I'll use joints and those standoffs to get it into the right place. I'm going to hide the top case there and use a joint to get this into the right location. So in the assembly option, I'm going to create joint. I'll find the back of this hole. So I want to get the center of this hole here. So clicking that, and I want to put that on the top of the standoff I created. If you're struggling to select the right point, you can hold down the control key and this will freeze your view, and you can select the center of that circle there. That moves the Arduino into the right location, and my motion for this is a rigid joint. I just want it to be rigidly located in place. Clicking OK, and that brings all of the components with it. I'll then show the top case, and I'm also going to create a joint for that. So at the moment, the top of the case can move around. I'll revert the position using the revert position button, and in this case, I can create an as-built joint. This is similar to a joint type, except you can use it for where you've already created your components in the place that you want them to be. So selecting the top case and the bottom of the case, I want to create a rigid joint. I could create a slider joint and move that up and down if I wanted to, but a rigid joint is perfectly acceptable in this case. You can always use animations later to show how this will work in reality. We now have our joints showing in the relationship. So the joint sits in this case for these two components, and the joint between the case and the Arduino will sit one level up in the design there. This symbol here shows us our joint, and you can change your settings if you want these to show under display settings. I'll leave them on for now. Just checking that analysis, I can see that everything is in place. We've got enough room for our components here, and they're sitting on the parts as we need them to. I'm now going to go back to working on the case, so I want to activate that component by using the toggle button here. I'm now going to use this Arduino design to drive the rest of my design and create the holes for these ports on the left-hand side here. I'm going to create an offset plane on this surface to drive some further work. So construct offset plane, I'm just going to click there and OK. We can then see that we have in construction, we've got that plane we made in the middle. I'll hide that one, and we've got this plane on the edge here. I'm going to create a sketch on that offset plane there, and I'm going to use the features of the Arduino to drive the cutouts here. So I'm going to use the project tool, so create and project, and I want to project through the components. So I'm just going to hide the top of the case. I'm going to use the specific entities projection here to capture this hole first. That brings through that edge that I want here. This time I'm going to use the entire body. So changing this filter to bodies, selecting that, we can see that actually brings through the design that we need to. Now we don't need these parts at the bottom, so I'll just edit the sketch lightly, drawing in a line here and on this side to create an enclosed section. Now we could use these projected lines as is to extrude the profiles we need for the connectors. However, I want to give some offset and some room in the design. Before I do that, I'm going to set all of these lines I've got to construction lines, and this will help when I'm creating the profile to cut later. So I'm going to do a box select from left to right to select all of those lines and then set them to construction. You'll see that they change from solid lines to dotted lines. I'll then create that offset with chain select on and create an offset of 0.5 here. We notice we've got a solid line there now. On this side, I do offset again, but I need to turn off chain select. If I do chain select and a 0.5 offset, you'll notice it has these squiggly bits down at the bottom. So I'll turn off that chain and manually select the lines that I want to create the offset from, making sure to select all of them as I go round, including that line we drew in. Just zooming in and out until I've got all of the edges. You want to make sure you select all of them so you have an enclosed profile. In this case, the offset is going to be minus 0.5. It's in the opposite direction. And clicking OK to finish that. When we finish the sketch, we now have two clear profiles that we can extrude cut into the design. I'll turn on the top case and create extrude. The profiles I want to select are those two that I just created, and I want to cut into the object. So I'll just hide the top case. It's going to be an extruded cut, And the distance, I want to go to object. Again, selecting that face means if we say change the shell thickness, this would automatically update the cut that we've got here. Before we click OK, we just want to check our objects to cut. At the moment, it's just going to be cutting the bottom of the case. So you need to turn on the visibility of the top case, make sure that's ticked, and then click OK. This means that the cut will cut both of those objects. And we can see now we've got that clearance for those connector ports. And we've got an enclosure here, which has enclosed our entire Arduino, which is all well and good, except if we're wanting to do some prototyping and we actually want to access these pins on the Arduino here. So I'm going to add some holes into the top case for this. Activating my top case component here, I'm going to create a sketch on the top. And I want to project through that Arduino geometry to help me in this design. So using the project tool, I'm then going to just hide the top case and find the top corner of each of these. I'm going to use the entities tool because I don't want to bring through all of the geometry on this. So selecting the top left point there and the bottom right point there of those pins, and the same over here. So the top left and the bottom right. That should bring 4 points forward into my design. This error popped up saying the object you're creating is not visible. That's because I hid the object when I was trying to work on it. We've now got those 4 purple points, and I can use a 2-point rectangle to create a sketch between them. So selecting that top left point and the bottom right, and the top left point and the bottom right there. Again, as we did before, I want to create some clearance. So I'm just going to use a selection box filter for all of those and change them to construction lines. I'll then use the offset tool with the chain selection on, and I'm going to do an offset of 0.5 to give us some clearance around those pins. I'll do the same with the other set down here. So selecting the outside and then an offset of 0.5. I can finish the sketch and use the extrude tool to create these as holes. So selecting the 2 profiles, turning it over, I'll just hide the Arduino and the bottom of the case to make sure that I can use the extent type to object. So again, if I update that design, it means that this will propagate through and will be able to automatically update. Now what we have is a fully functioning Arduino case, and we could export this for 3D printing now. But I'm going to add some aesthetic features just to finish off that design. The first of which is going to be a chamfer. So making sure my case is activated, modify and chamfer. And I'm going to add one to the top and bottom. Again, I'm going to use a chamfer of 0.6 millimeters. It's already looking better like this. I'm going to add in some pattern to the top of the design here. I could print it as is, but let's add in a feature on the top so that we're using less material. So activating the top case, I'm going to create a sketch on the top surface, and I want to cut out this material that's between it here. So I'm going to create a line down the left-hand side between these 2 points. And I could just create a line from here to here and cut out all of that design. But I want to make something that looks a little bit more aesthetic. So I'm going to create a construction line. L on the keyboard is a shortcut for line, and construction you can either select from here or X on the keyboard. Create that down there as perpendicular to the top. So just wait for that right angle symbol and snap that in there. I'm then going to use a spline. So turning off my construction from this point to this point, and then using these drag handles and dragging those to this point to make sure that it is tangent. So this green handle, and then snap it to that point. So already that's quite cool as is, but I'm going to add in a grill pattern. So in order to do this, I'm going to inspect some dimensions. So inspecting from here to here, we've got 3.41, and inspecting from here to here, 51.67. So I'm just going to take a note of that dimension and use this to drive a pattern. It'd be really difficult to work out the numbers, so I'm going to use some cool features to help us. So first of all, I want to create 2 lines, 2 horizontal lines, and just place those randomly. The first of which I'm going to constrain to the top of here. So grabbing that point there and the top right hand corner, and then going to dimension from there to there as the 3.41 that I measured. And this will put it in line with that bottom there. I then want to create a rectangular pattern. Selecting the two lines that I just created, I'm going to drag them down to make sure I'm working in the right direction. Now I've worked out that I want 10 of these in the design. So you can see here we've got some smaller gaps and some bigger gaps. Now rather than trying to work out the exact number we need here, I can use that dimension that I just measured, which was 51.67. And then we want to minus the 3.41 there. We can see that those lines line up perfectly there. And we just change the quantity to 1 in that direction. So clicking OK, we can see we have this cool grill pattern. I'm going to finish the sketch, hide the bottom case and the Uno, and again create an extrude, just selecting those big bands on the design there and doing the distance to object and selecting the bottom inside face. Clicking OK, we can then see we have this cool grill pattern that allows us to see the inside the Arduino and might even provide some cooling if needed to that electronics. Now this case is perfectly adequate in this particular finish of the design. However, I wanted to show you a few extra features if you wanted to add these to your design. I'm going to activate my top level case and go into the plastic tab along the top. So in plastic working, there are some tools here that are available to you if you add in the extension. Extensions are available in the top right, and to be able to use the plastic working, you'll need the design extension activated. Once your design extension is activated, you can create different aspects such as webs, ribs, bosses, snap fits, and in particular lips. We're going to add a lip between the two halves of the case, just to give it a little bit more security in the design when they're snapping together. So I'm going to roll my design back to before lots of the features were added, just to help with clarity on the design. So rolling this back to before I made the two components, we can see there that we are working with the design as it was, like this. Keeping my analysis turned on, I'm going to create lip, and I'm going to select the inside face of the design. Now you can create a lip, a groove, or you can create a lip and groove. In this case, I want to create a lip and groove, which is going to modify both of the features. You need to select the pull direction you want to create this in. So I want to make sure that this is along my Y plane. When you first open up your tools here, well, come up with a warning to say you've got no plastic rules assigned. In this case, because we're going to be 3D printing it, we don't actually need to assign any plastic rules. So it says, would you like to assign plastic rules or would you like to continue? So in this case, I can click continue. We don't need to set any extents in this case, and you can click OK. This will then create a lip and groove design into your casing. So we can see here, we have the top and the bottom with a lip and groove design on each half of those intersecting each other. This is another reason why we used hybrid design. The lip and groove tool edits two components at one time, and internal components within the hybrid design type is the only option that allows us to do that. If this were done as a full assembly, the lip and groove option wouldn't be available to us. I'll then roll forward my timeline to the end of the design, and we can see that has propagated all the way through. And there we go, we have a finished case that is possible to 3D print for our Arduino Uno. All that's left to do now is export these files as mesh, which you can do by right-clicking on the file, save as mesh, or by using the 3D print utility, or even going into the manufacturer workspace and setting up your print from there. If you're interested in this, please do check out our video here for that. Otherwise, if you've got any questions, please do post them in the comments section below. If you've liked this video, give it a thumbs up, and I'll see you in the next one.